Thanks everyone for coming out today. It's my first public talk, so I just clap to sort of keep the slides are self-explanatory, so just click through and finish off. So this is a quick talk on subdomain takeover attacks. It's an attack vector predominantly for web-based attacks. It doesn't get much coverage. It's really popular in the bug bounty space. If you do public bug bounties and those sort of programs, if you follow those sort of logs, you'll see these subdomain takeover attacks. But on pen tests and in this attacking world when you're managing DNS, it's not really getting much light. So I'm going to do a quick talk today. We're going to talk about very, very high level what are. Sorry, come in. Have a look in this thing. We're going to have a quick talk of what are subdomains and how that sort of DNS piece looks. And then different ways that we can try and take over someone's domains and serve their own content. I've got quite a few demos. If they don't work, I have recorded them, so we'll see how we get on. So, who am I? With the obligatory. So, my name's Simon. I'm a director of my own company called Pump Security. We handle DevSecOps. So, we work with numerous clients, helping them out with DevSecOps. Each client generally has unique challenges. We've worked recently with a client who had a bug bounty program we were helping to manage, and they had repeat subdomain takeovers. And they had this problem with the way that they were deploying DNS because of the large number of developers and the way that development was distributed throughout the organisation, that DNS misconfiguration was common, and there's no tooling really to detect these conditions. So I'm a DevSecOps enthusiast. I love automating security. That's one of my passions, really. I'm also a Python developer, so back end of this talk, we just released a tool within Python. Deep dive into that, anyone wants to talk about that afterwards. Obviously, live for security and massive geek. So I'm currently doing an electronics project for a conference patch. So if there's any electronics geeks, and there's a robot building going on here, so you can come and find me after the talk. Love you here. Okay, so what are subdomains? So if we look at the slide here, we can see in the white, we've got the TLD part of the domain. It's the top level domain. So in the world of DNS, we have roots in servers, and they will maintain who, for those TLDs like .co.uk, .com, .io, who's responsible for looking after the name servers, the DNS servers, that are going to tell you where to find the bits in blue. So in this case, our website, unsecurity.co.uk, top level domain, .co.uk, hosted by Nominet. They have some name servers, and we go and buy unsecurity off them. So that's the cost of that, because they've got to maintain those DNS servers, registry records, and who is stuff, and all that sort of stuff. So I go and buy Pump Security. But actually, I've got lots of things on the web. I've got mail servers, web servers, a documentation page. I want more domains. I can either buy more domains, or what we see commonly is subdomains. So I've got www for the website, blog, docs in this case. So that's a top level overview. Subdomains. I mean, it's not rocket science, is it? Most people know it anyway. Those subdomains can point at an IP address. Ultimately, the idea of DNS, obviously, is to turn a friendly name, like www.pumpsecurity.co.uk, into an IP address so the computer can connect and serve that page. Along that path, though, we don't have to return an IP address. We can return a CNAME record and say, go and ask this place. This knows the IP address. In this case, we can see docs.pumpsecurity.co.uk. It's got a CNAME record saying, go and ask this person instead, to pumpsecuritydocs.github.io. And this is a pattern we see more and more now. So people are using SaaS services like Netlify, Amplify, GitHub. They host the content and you just CNAME up. So service desks, probably Zendesk or ServiceNow. You go and say, right, you go over there. So in this case, docs.pumpsecurity.co.uk, CNAMEd off to GitHub. In this case, no one's registered that on GitHub. And now we have the error condition. So docs.pumpsecurity.co.uk is present on my DNS server. It will resolve that CNAME, but when you go and check the CNAME, it doesn't exist. Because I haven't set it up GitHub. And this is more common than you'd expect. So we're going to do a demo now of a GitHub page is takeover. So if we detect this error condition, how do we serve our own malicious content from docs.pumpsecurity? Let's give it a go. Well, it's not going to be docs, it's going to be wiki. If I did docs yesterday, I got burnt it. So let's see how we get on. back on the slide deck. I'm stuck in the slide deck. So if we go to so for this demo, rather than serve an accurate DNS, I'll just put it in my host file.
Lost the screen.
He's not lying.
Try to pray for the demo goes first.
So I'll just unplug it and plug it back in. We're back, yeah?
It thinks you're sending blank. That is being detected.
There we go.
Okay. Awesome. Okay, so I've rigged it via my host file, so that's just a way of shortcutting DNS resolution. So I haven't got to put it on a DNS server. I did originally have it on DNS servers. We used Cloudflare for our DNS, and just about how it runs. So the demo's host file. So if I ping this, the IP that comes back here, I know the GitHub Pages IP. So we can configure GitHub Pages custom domain and give you 2 A records, 2 quad A records for IP version 6, and 1 CNAME. So you can use any of those, and it'll get you to GitHub Pages. So wiki.pumpsecurity.co.uk is pointing at GitHub Pages. And if we browse that in a browser, we get this. So in the background now, it's got the IP address of GitHub Pages, it's sent the traffic there, it's got to GitHub, and GitHub's gone. There's no page here. So this is the error condition we want to detect. So in this case now, as an attacker, I should be able to get my own GitHub Pages site. So I've just created a GitHub Pages. Throughout these demos, because I'm a bit lazy, everything's a pump security organisation, but there's no ownership of this domain here in GitHub. It's just that I didn't want to set up a new account. So I've got a GitHub Pages, and in the Pages config, I can say what domain I want it to take over. So in this case, wiki.pumpsecurity.co.uk. Pop it in. Okay, so next says your site is live at wiki.pumpsecurity.co.uk. As far as GitHub's concerned, and every SaaS provider has a different sort of stance on this, but as far as they're concerned, that's a fairly secure mechanism, right? Because you have to point your DNS at it. Attacker can't point your DNS for you. But we've already seen that someone has pointed it and not configured it. So shortly, it'll just take a while for that to get set up. Firefox is friendly. Corporate policies. Right. As you can see, it's no longer a 404. Yes, HSTS has trumped my demo with it. Right, so yesterday that was working fine. So what we should see is 404. And then eventually GitHub serves it without HSTS errors, and we get this domain has been taken over. And that's because I'm serving that from my Git. So in that case, if that was a real situation, we do see this, and you can look at HackerOne and you can see these takeovers. Someone's had that condition, they've configured it in DNS, maybe they've had that registered on a repo somewhere for their documentation, and they don't use it anymore, so they've deleted the repo. No one ever maintains DNS, it's just like a set and forget. So it's still there, you take it over. So that's attack number 1, which is hopefully fairly self-explanatory. The second attack we're going to cover is one that I was only stumbled across about maybe a month ago. It's quite new to me, and I thought it was quite interesting, so I thought I'd show it here. So when we talk about those TLDs, I told you that they know when you register a domain, you will tell it, I'm going to host my records on a name server. Ours is Cloudflare. You can use Reaper free in AWS or DigitalOcean, Google DNS, GoDaddy, whatever. So you will configure your DNS records there, and you will tell your registrar, whether that's GoDaddy or Nominet, my DNS servers are over here. So when people go and look for www.unsecurity.co.uk, it knows which DNS server to go to. So that's what the registrars do. You can do the same trick to delegate part of your domain. And we see this more and more commonly now with sort of DevOps movements and agile practices. We want developers to be able to create their own DNS records themselves. They're already deploying networks and AWS and VMs and websites. They want to be able to create their own DNS records. We don't want to give them full control of DNS from a security point of view. So what we can do is say, right, if you want there we go. So the developers now at dev.unsecurity.co.uk, what we can do is say, right, you go and set up your DNS somewhere you want to go, Daddy, Cloudflare, duty free, and we'll set an NS record saying anything .dev.unsecurity.co.uk is over there now. So then when someone goes to www.dev.unsecurity.co.uk, it finds the right place that the developer wants, but the developer has no control over anything .unsecurity.co.uk. Does everyone get that? Yeah. So we can delegate through named NS records. What we find in some cases, particularly AWS, is that if you left that dangling or you set that wrong, it's pointing at AWS. In this case, the demo we're going to show, the NS record is pointing at a SaaS DNS provider which you haven't configured. And it's the exact same attack as GitHub Pages. We configure the NS record ourselves, the domain ourselves, and we can serve whatever we want. .test.unsecurity. That's the type. So let's try that. AWS root free name server takeover. I've got it on video in case it all goes horribly wrong. Okay, so in this one, slightly more elaborate, we have two AWS accounts. I actually bothered to separate these out. So we've got an attacker with no DNS. For anyone who's, well, as it turns out, 5 hosted zones that I haven't cleared up. Well, we can use test from security. So we've got an attacker with an AWS account. If anyone's not used Root 3, it's DNS hosting. So public zone, you put your registrar at it, you serve DNS records. And we also have the victim in this case. So he's got the pump security domain. This isn't our actual DNS setup, that's on Cloudflare. So you've got pump security domain. So in this case, I want the developers to use test.pumpsecurity.co.uk. I don't want to give them permissions to the full pump security domain. That's just, they're doing all deadly stuff and I don't want them messing with certificates or mail routing or anything that might break this. So what I'm going to do is create them their own one. So let's give it a create. So test.security.co.uk. Create the zone. It doesn't care. Same sort of opinion as GitHub. These names don't have to be set correctly. That's their security check. So there's no way that they check that that's our own security.co.uk. Doesn't really matter. And then what happens here is Amazon have lots of name servers dotted all around the globe. They've provisioned this zone that I can now control. This is the legitimate admin one. On these 4 name servers. So dotted around the globe, there's 4 name servers owned by Amazon. And they now host my records. And as I add records here, they get provisioned onto those servers. So then the last step for the admin is to configure that delegations. Hosted zones. Go back to our parent zone. Create record. We're going to create that NS record. Yeah. So I create a test and I point it at the same NS servers, and that completes the whole flow. But what we're actually going to do is do 4 admin and 2 teams in the test. So we've got a typo in there. Okay. So now we've got this test.pumpsecurity.co.uk, and on the parent we've got test with an extra T.pumpsecurity.co.uk. So if we go to DNS television and I look at the screen and you just can see anything for like 10 minutes. You just go, oh, it's kind of terrible. Let's just ignore it. So what we're going to do is this test.security.co.uk record has been pushed to this Amazon DNS server. So if we query that directly, we should see that it exists there. And we can do that with a scope of authority record. So if we do, I need to get the IP address of that AWS DNS server first. Do that. So if I do an NS lookup for test.security.co.uk against the Amazon DNS server, this should come back with stuff, right? Because that zone is configured on that name server. It's all well and good. But what we saw in the parent was test with 2 T's, right? So if I do that query review, so that domain, that zone is not configured in AWS on those name servers. Which means an attacker can keep provisioning zones in AWS until he gets his placement on that name server, at which point the flow is complete. Does that make sense? So I've said, you go over to these name servers and you will find test.t.security.co.uk, and it's not true. But as an attacker, I can keep putting zones and routes to free until a happen chance ends up on that same name server that I've configured. And we can see that now. So let's try and brute force it with my very, very shonky Python script. So what I'm going to do is, these are the name servers that it should be. In fact, I'll show you. So these are the name servers it should be sat on. I'm just going to feed those to this script. Should have shown the recorded data because of interest. Right. NS root test. Okay, so the 2 T's, because that's the one we're trying to put on those name servers, and we want it to go onto these name servers. And then every dot is the script putting a zone on AWS. So every time it does that and it doesn't get the right name server in the list, it just deletes it and moves on. So the dots, so you can see that, I put the dots there just so you can see that, there's a bit of brute force here, but it's not. They haven't got like a million name servers, and therefore this would be unachievable. The other thing is there's 4 name servers. DNS works a bit weird in that the closest name server via ping will be returned. So if you take over one, you might find in certain parts of the world you've got an effective takeover. If they've misconfigured it and put 2 correct ones and 2 wrong ones, and you get the 2 wrong ones, in some parts of the world you've got a takeover. In some parts of the world you haven't. Depends on how the DNS is working. If they've misconfigured, we're not getting any from it. If they've got them all wrong and you take over one, fingers crossed, depends on how the DNS resolver is going to work, it's going to keep trying all of them until it gets a hit, so maybe one's enough. What we find though is you can keep creating zones in AWS. So you might find, okay, one zone's got 2 on, another zone's got 1 on, and then eventually you get all 4 split over 3 or 4 zones in AWS, so you've got full name server takeover. This is riveting stuff like that. I've got this recorded as well, so we might end up skipping. Oh, there we go. So we've got the first one. You can see it on my screen and I'm walking over there. So name server 15378 is now been registered on that zone. So we've got the first one of 4. We've actually got 47 as well. I think it does seem to allocate them in pairs quite a lot. So you can see in that second line of the output I highlighted, we have NS 1570, which we're after, and we're after 378. So we've got 2 allocated. So now we've got 2. So hopefully this one's a bit longer. We get the other ones. At that point now, the flow's complete. I'll just start serving records. So because this is a name server takeover, anything .test.security now, I can serve. So I can generate certificates. I can do mail records. We'll go into this in a minute anyway. So from this vantage point of an NS takeover, it's a lot more powerful. That's what we can do. If we switch over to the attacker's view of what's going on. You see all the zones that I should have deleted before the demo and didn't. And then test T at the bottom there is the zone. So Z014 should hopefully match up here. Yeah, so if I had those records, I can do that. If I was clever, I could have wrote a Python script that would put some like malicious record on there or something. But so we'll probably find that this number should be like changing. Every so often they like rate limit and then it stops for a little bit and then still catch up and start doing it again. So I'll probably rate limit. What we should see is like one appears and it doesn't match, it gets deleted. But we're not seeing that. Oh, is that what? Oh, yeah, you probably.
Windows, yeah.
Oh, I'm so glad I've got a demo assistant. That is exactly. that's why I brought him along. That's exactly what was happening there. Yeah, okay. Well, I only needed to do that. Right, so that's there's the demo. Okay. So this one I haven't got a demo for. It's a bit of a honourable mention. Unresolvable JS includes. You see this on the bug bounty platforms. If you aren't looking for bug bounty platforms, by the way, a lot of programs don't publicly disclose, so you don't see what's happening. But a lot of them do. So like Uber are quite good at it. Ubiquity. I sort of go on HackerOne, but there's other platforms available. And then you can see what these people are doing, and it's almost like you're at the bleeding edge. The bug bounty programs now, particularly public ones, there's that many researchers in such a contested space that they really have to fight tooth and nail now to find things. So some of the reports are quite interesting. So you occasionally see these, and this attack is also really common on WordPress plugins. And the gist of it is, this is the Pump Security website. You can see that there's a widget somewhere doing something, and we fetch it from Calendly. So it's not hosted by us. We fetch it from Calendly. It does some stuff. This is really common. You might have a WordPress plugin that, I don't know, rotates cat memes or something, and that is using some JavaScript from a developer. The plugin's not been maintained for 6 years. Developer's domain just expired 5 years ago. That JS is just broken, doesn't really affect you. Your cats aren't rotating anymore, but no one's really complained. And then an attacker sees that, registers the domain, swaps the JavaScript, and then I'll just redirect your domain or just script, install script, and just payload it. So honourable mention, nothing to do with DNS really, but it does allow you to take over a subdomain. So what? These are actual domains that were taken over on HackerOne public reports. So it's like, yeah, you always think most of the times that you see these takeovers, they're really obscure. So developers got a branch of a website and this really weird URL. And you think, if actually I got sent that in a phishing link, I think it's weird anyway, and I wouldn't click it. But these ones obviously are pretty legit. Signup.uber.com. If you've got a link for that, you probably think that's a legit one. You know, we tell users how to like check for links and hover over it and all that sort of good stuff. And all these look pretty darn good. If these were NS takeovers, and they weren't, so I'm sticking the fabric here, but if these were NS takeovers, we could start putting mail addresses like help@signup.uber.com, and people can reply to those email addresses. They aren't just spoofed email addresses. We can control the SPF records and stuff. We can get this stuff to pass, and then people can reply to it. So it's quite a bit of danger there of someone abusing your brand for phishing and fraud and that sort of stuff. And then the biggest danger, if you haven't got the correct mitigations in place, is something we call loosely scoped cookies. So a website will have cookies. We haven't got a demo for this. We'll have cookies for all sorts of things. So your preferences, if you want dark mode, tracking, lots of tracking cookies everywhere. Also, if you log in, your session ID is normally stored as a cookie. So you don't log in every page. You just keep sending them a cookie. And the beauty about cookies is they get sent by the browser automatically all the time with every request. So we haven't got to write any code to do that. We can just read the headers. So if we imagine in this scenario, we've got 4 domains here: pumpsecurity.co.uk, www.blog, and then the docs ones. This is the same scenario from earlier before I changed docs to test. The docs one's been taken over. If I've got cookies on punksecurity.co.uk that are loosely scoped, so they are accessible by subdomains, if we send a phishing link to docs, I will get the cookies from punksecurity.co.uk without having to do anything. Literally, as soon as a person opens that link, I will see the cookies. And we can see that. So this is a punksecurity.co.uk. We haven't got any login thing, it's a static website. But you can see these are our cookies. You can view them in the developer console of Chrome. And all the cookies are loosely scoped. They start with dots, which means they're loosely scoped. There's no dot. They will only get sent to that exact domain. If there is a dot, any subdomain will see the cookies. This is quite common. I think I'll just pick a random website and shove it in my demo. That was a bit bad. People are getting better to it now. You probably won't see this on Facebook and stuff. It's more like someone's got a website, it's got maybe a back-end API. So it's convenient that when you log in, they loosely scope it, and then every time you do an API request, the header gets sent. That is not how you should do it. You can use bearer tokens and all sorts of API authentication, which is what you should do, but sometimes it's convenient not to. So this is what we're after. So those, if I was to get a subdomain from security, I would see these cookies. And if calendly.com, if I got subdomain taken over those, I get them. So I'm going to show you a demo. It is a really good one. It says. Okay, so the idea here is if I go, not sure if Firefox is my friend again. So example.org is convenient because there's now HSTS, and I would have done punksecurity.co.uk, but it kept on upgrading it and there's an SSL pane, so I'm just going to use this one. So there's no cookies on this website because it's just like a thing. So I'm going to add one. So here's my auth cookie secret. You see the domain there. I don't know if you can see that. There's no dot at the start of it. So the default when it creates the cookies is scoped. It will only be accessible on example.org. So I, as an attacker, have taken over subdomain.example.org, which is this Python script. When it runs, it dumps out the headers that come in. So you can see that there's no cookies being sent. If I change the scope of this cookie to be loosely scoped and revisit the subdomain, as if by magic, we have the cookies. There's no attack to make, right? I can just do this. And this is quite useful because if you have like a really weird way, rather than sending someone a link, you can send them a link to a different site. You just have images or from the subdomain. That web request will come in and you'll get the headers. So you can't execute any JavaScript in that environment, but you will get the headers and you can still get cookies. So there's interesting vectors for getting those cookies now. So that's what we call loosely scoped subdomains, and hopefully that's pretty obvious as to why if you've got a subdomain takeover and someone is using loosely scoped cookies for auth tokens, they're in a world of pain. Okay, we are nearing the end now. So how do we defend against this? Periodic audits. So and I've seen this both internal and public facing. Public facing DNS maybe gets a bit more attention, but I'd say it's pretty darn common that people just don't ever go back and look. No one does a periodic review of your DNS. They're all these records that we don't need anymore. It's just not done. You go and set something to enable a service, and when that service is decommissioned, a DNS cleanup just doesn't appear to be a thing. These same attacks can be used on internal DNS, which is rife with this sort of, it's even worse. To the point that Active Directory supports scavenging, and you can just age out records because it's just full of stuff from years ago. But these same vectors are difficult to discover internal stuff, obviously, over the internet, but the same vectors apply. So we need to start doing better DNS hygiene, really, education piece. Bug bounty programs. So when I go into a tool in a minute, we wrote a tool to find these things. We ran it over public bug bounty programs. There's a web resource called Project Discovery. Come across it. They have all the public bug bounty programs. They have brute forced using their tools, the subdomains, and they release it. It's a daily release. So we downloaded all of those. Most of them are nonsense, but we ran it through. It was a good, maybe like 70 million or something records. We only found 3 takeovers in the bug bounties. because there's so many people looking in this space on bug bounty programs. So one of the best mechanisms really to keep your DNS is to use bug bounty. At a cost, you're probably going to pay $300 or $400 for every detection. Extend pen testing scope. So I've been pen testing for years, and courses I've gone on, books I've read. Run books never really care for DNS. It's just, we've seen this in other things. So one of the things that we push at Punk Security from some of the incident responses we've done is SMB servers as well. There's certain things that, because it falls in sysadmin land, that just don't fall into pen tests. We like to find CVEs and for overflows, and then the fact that a file server is fully accessible or your DNS is full of nonsense, we don't really care for it. And then in green at the bottom there is the tool we wrote, DNS Reaper, which I'm going to give a quick demo of. Hopefully. So what is DNS Reaper? It is a Python-based tool. It's in a Docker image, or you can read it directly from Python. You give it a list of domains, and it will check them. We have 61 signatures, 2 are disabled by default, so they're a bit noisy. It will check lots of signatures, exactly like the GitHub one we saw today. Does it go to a GitHub? When I go there, do I see the GitHub? This isn't registered. There's 60 of those, includes the AWS one. If I resolve this, is it not resolvable on the name servers provided? If yes, I have a match. So you can give it domains and it will run those signatures, or it will fetch them. So you can point it at AWS 53, which we'll see in the demo, Cloudflare, DigitalOcean. If you've got an internal DNS server, you allow zone transfer, it will pull the record and scan them. Lots of stuff. My mask over. No. Oh, good. Okay, so yeah, 60 signatures. We also pattern match the web response. It's all open source on GitHub, so if anyone wants to add signatures or see how this works, or just fork it, what have you, go for it. And then you report to screen, so you can use it in a pen test. We dump CSV and JSON, so you can use it for automation suites, build automatic reports out of it, that sort of good stuff. And because we're DevSecOps, it will fail a pipeline. So if you deploy to 53, run this straight after. If it detects any takeovers, fails the pipeline and flag. So use cases for its periodic audits. We'd like to see people doing something to audit DNS, and we wrote this because we think it's what you should be doing, but whereas they were open to suggestions. Scan for bounties to get money. So we did find 3 bug bounties, but they're all on programs that don't pay any money, fortunately. So we didn't get any dollars. And then prevent bad deployments. The scenario I just talked about. Deploy to route 3. Scan the thing straight away and say, oh no, that would cause. I mean, in an ideal world, you deploy the zone to route 3 and wouldn't update the registrar, and then you can block it before it ever goes live. But at this stage, if you were deploying and scanning straight away, you'd have like a vulnerability window of 30 seconds. Crazy. Okay, got one more demo to get through. I'll do it live. How long have we got?
About 2 minutes, but how long's the demo?
I don't know.
It's about 2 minutes.
6 minutes. Okay.
No, it's fine. If you want to go do 6 minutes, it's all good. Carry on.
Right, here we go. I'll just use I'm going to use the Windows terminal rather than command line. It's full colour. You get to see all the lovely effort we've got into colour. So you can run DNS Reaper via Docker. And it helps to spell your name right. Okay, so Punk Security. So that's what you get when you run it by default. So you can see you've got a list of providers here. This is the mechanisms you've got to provide domains. You can give it a file full of domains. You can give it a single domain with a command line and test it. That's all by using DNS lookups. Or you've got providers, so Zone Transfer, Cloudflare, AWS, Azure, Bind, and DigitalOcean. So if you're using like GoDaddy, you can generally export your domain. Not sure if you do it by the API, but by the UI, you can export it to a Bind zone file. If you export that, you can scan it then. So if you can find a way of rigging that up to give you some automation. Right. So we're going to go for the AWS one. Please switch over to, in fact, I'll do it on the we go to DNS Reaper and drop into the docs here for the AWS one. We have kindly documented out what you need to do to get AWS up and running. So if we run this with help, we have some information here. So for AWS, we provide the AWS access key ID and the key secret. These are optional for this provider. It's not usual to be optional. That's because if you run this in like a Lambda or container as part of the pipeline, you can just assign it an IAM role as usual and it will just use that. But in the case of you run the command line, you need to give it keys and stuff. So we need to go and create these keys to go and run it. So the plan is here, we will go to the attacker one, delete this zone. So the victim is back. Is that still in the background? No. So it's back to the error condition. The test T is not on the name server, is present. So if we switch back to the victim and just create a user for the DNS Reaper to use, it will connect, download, and hopefully you'll see that it detects that error condition that we've created. If not, I've got it recorded, or watch it on it. Right, create a user. Let's skip over this. Oh, we need that. Oh. That is how not to do it. Let's go back here. We'll just rotate that. DNS Reaper 2. Cool, right. So I need that access key ID. That was the secret. Key ID. So those are the two settings. All it just is give us permissions to audit DNS. So hopefully we've put the exact policy you need up on GitHub. She's get zones, list zones, and list the records on the zones. So we add inline policy. In. Give it a name. Goose. Okay, so that account now has got the privileges it needs. So, we should be able to Docker run full security, DNS Reaper, and we can use the AWS provider and provide those credentials. Excellent. So, connected to AWS, downloaded that, got 3 records in total across the 2 zones. And then we've got 2 detections for the same domain. And that's because if you see, we've got 2 confidences there. We've got a credential and a confirmed. This is in the JSON, so you can filter. So we do a generic. This zone is not on that name server. So if you're using Google DNS or something that we don't support yet, you will still get a signature for it because we haven't got a specific signature. But we can see that the zone's missing on the name server. Chances are when you see these, it's because internal name servers or something that the victim's already controlling. There's no attack vector there. But hopefully it's a SaaS provider, we haven't got a signature for it. You go, can you write a signature for this actually? It's detected in the future. And you get those detections. And then you've got the confirmed one here, AWS. So if it's confirmed, we've looked through the HackerOne reports and we found reports to say that this service is attackable by NS Takeover. So in this case, it's the same domain, but for this signature, we've seen the pattern that it's AWS DNS. So we've confirmed it's AWS DNS and it's not on the zone. And therefore, got confirmed takeover. And you can see that it did that. Connected to AWS did that, run through 60 signatures in 1.29 seconds. So it's not going to ruin your pipelines. And that's it. We've meandered all the way through to the end.